Oscar. Getting names. Namdar.
Don't forget the puppy.
Layla.
Or Leia?
Lila. You got so close. You get full credit.
Not enough coffee.
Just caffeine gum. GM, more coffee.
Just life, McChan, just life. All right, here we go.
You want to take over today, Chase?
Yeah, I'm leading all the technical demos.
Chase is on tech demos. All right. Who got Alchemy shirts? Did anyone not get a shirt? McJam? McJam and Cito? We're going to take a picture later, so we got to take an Alchemy picture. We got a special guest here today. He's somewhere. I don't know where he is. All right, week 4. We're over the hump, right? We're getting into Solidity. This was a tough week, a lot of front end, but hopefully you guys got through it. Maybe we should have done more React maybe next time, but I think this is like a good practice for building dApps, right? Part of all dApps is having a front end and then the Solidity contracts. So we've built our way all the way up to understanding Ethereum from the state model to building a front end for dApps. Now we're going to get into the back end, which is working on the blockchain and writing smart contracts. Real quick update. Yesterday, the ETH SD, we shot podcast number 3 for ETH SD with Al from Alchemy University. This was a lot of fun. We talked about scaling strategies, the importance of culture, especially in boot camps, and how other cities can sort of take what we've done here at ETH SD and this playbook that we've created and essentially build up their own communities through education. So super exciting. And then real quick, or not real quick, but we've got a special guest here, Al. He's going to come up and say a few words about Alchemy University. Yeah, maybe you guys have seen him through the videos, but he's live. So let's give it up for Al.
Speak faster.
Let's go. I don't know who speaks faster, me or Al.
Here you go.
All right, thanks. Someone made a joke on the ETH SD Discord yesterday that I think Chad posted a picture like, Al from Alchemy is here. And someone replied to that like, does he speak in 1.2x in real life too? Because, there you go, shout out. And, because we do a bunch of videos for the Alchemy Learn content and a bunch of you are exposed to them, unfortunately. And you guys are smart and 1.5x through them, So I'll try. Does that sound good? Okay, wait. Okay. Thanks. Okay. Wait. Okay. Hey. What's up? Let's go. So, hey to the live stream and to the remote folks. I'm super honored to be here. Chad, Chase, the rest of the team, all the mentors that I met have been amazing. I worked and also shout out Edge Wallet that they are pushing innovation like this in San Diego. Because they could have, I don't know, like any other company could have very easily said like, no, it's our space or whatever. I don't know, like something bad like that or something. But no, they recognize that it's good to kind of harvest and push innovation in the space because at the end of the day, you're getting a bunch of talent centralized into your own space. So they're pretty smart to recognize that right off the bat. So I won't say too much except maybe just speak to ChainShot's origin, which is the startup that was acquired by Alchemy and is now kind of, the core team is now Alchemy University. And just also shouting out that I did work so I was shouting out Edge Wallet, but I worked from here yesterday as well, and the team and the folks going through the current cohort, which is the first cohort ever of ETH SD, right? And that's so exciting to say because that implies there will be more. And they're all amazing. We just worked for a couple hours out of here and it just felt like, I don't know, we had known each other for, a couple of years. So that's all good. I'll just speak to ChainShot. It was founded by Dan Nolan and Cody McCabe, 2 amazing builders, OGs of the Web3 space. And they built the early ChainShot implementation at ETH Denver. And their kind of like problem statement was kind of, Web3 education is underserved and it's really tough to learn smart contract development. And that was like their main problem identification. And their use case solution was, let's build like this cool little, app that teaches smart contract development and JavaScript and interacting with smart contracts and what they are, all kind of packaged in one. And they kind of also built all these cool proprietary technologies like an IDE and all these cool things. So they started at ETH Denver in 2018, won that hackathon, and kind of got their initial funding via that winning grant, and went on, kept building, kept going through scaling a tiny business into a startup that was successful enough to be noticed by kind of a Web3 pillar like Alchemy enough to be acquired. And now what Alchemy did was we used to charge $3,000 a seat per bootcamp. Enter license. Okay, there you go. Nice. Oh no! But,
Why'd you troll him? It's out of respect. It's demo mode. It's demo mode.
oh, exit. And then,
Swipe to the network monitor.
hey, nice. Thanks, guys. Group debugging, it's funny how that would happen, and for context, and I'll just say this real quick, we used to teach remote classes. So the chain shot model was get a bunch of students into cohort-based, which is very much this model, but it was all remote, and we'd kind of instruct remotely and live and just kind of cover concepts and run through activities all together. But it's funny when that would happen live, it was just technical difficulties. But how, I don't know, we just group thought a solution out of that in a way that in remote would have just been awkward and everyone's muted and it's weird and stuff. But yeah, so ChainShot, they recognized this problem, solved it, scaled, covered that, and I kind of lost my train of thought a little bit, but 3,000, thank you so much, Bapic, shout out. So we used to charge $3,000 a seat per bootcamp, which is kind of, in the bootcamp space, it's kind of relatively low, to be honest, because we used to do 10 weeks, 10 continuous weeks, 4 days a week, 3 hours a day. And that was fully instructor-led, and all these other boot camps that are, kind of serve a little bit more what I call a little more predatory models, where they're they charge you $15,000, and if you don't succeed in that first test, you're dropped, and your tuition is kept and stuff like that. These boot camps are out there. You can Google them. So we did kind of charge relatively low on the spectrum of boot camp pricing for the services we offered. Anyway, $3,000 a seat. Alchemy acquired us and said, no, we want to bolster the Web3 development space. We want to get more developers learning Web3, learning computer science fundamentals via Web3. So you guys are going to make your content free. Or our content as Alchemy University, and that's what we're doing. We're currently in early access, which all of you guys are here now. If anyone is watching this and does not have access to Alchemy University, reach out to Chad or myself, and we are very happy to get you one of the early access NFTs and get you in there. We will public launch soon, but that is our goal. Make Web3 education, which was initially kind of barriered, as free and accessible globally as possible. So that is what we're doing, and thanks to the efforts of Chad, Chase, the rest of the ETH SD team, that is just incredible to see the scaling models that they are applying to a kind of free and continuous Web3 course like Alchemy University. So yeah, thanks guys. Thanks so much for being here. Woo, let's go. I'm so excited for your demos. Let's go. All right.
Right on.
Yeah.
Yeah. Thank you, Al.
Yes, sir.
Appreciate
Yes, sir.
you coming out here and speaking and talking about the what Alchemy Learn has been doing.
Yeah, thanks.
Yeah.
Chad.
I think something really important that I'll mention is the fact that this education is free. We can pass that on to you guys, right, and make this bootcamp free of charge, right? So shout out to all the mentors that are here, that are supporting all the students. Let's give it up for Cloud, for James, for Adrian. Who am I missing? Toby, because I haven't seen you in 4 weeks, Toby. That's why. Awesome. So real quick, just we do this every week, the bootcamp logistics. We're doing the intro slides. We're going to have time for questions and roadblocks. Then week 3 student demos. Really excited to see what you guys have built this week. Week 4 slides. We have Adrian today who's presenting his slides. And then we're going to go into reverse classroom and just work through the material. So week 3 recap, we talked really about Ethereum, interacting with Ethereum, a little bit about proof of stake, what gas is. Transactions was a big topic this week. So understanding how to actually create transactions. They're just JSON blobs, right, that you send off as RPC calls. We talked about front-end libraries for interacting with blockchains, so specifically ethers.js, but there are others like web3.js. And lastly, you guys built a block explorer, which is super exciting. So who's going to pitch me an idea to compete against Etherscan?
Oh, God.
Who's taking Etherscan down? No one? Come on, guys. It's just a little app, right? It's just really small. Not that many daily active users. I'm just kidding. Real quick, just to go through the rubric, and shout out to Cloud who really helped form this rubric. We broke this down into different sections this time, so a little bit differently than before. We're always going to have a basic section, which is, were you able to briefly describe your project in the GitHub README, and does it compile and run, right? Like these are just, you got to have these. We had a section for design because this project is, there's heavy use of design in this case. So were you able to properly use CSS or SAS or SCSS to implement this project? There was a lot of React, right? So do you understand how to use React props? Were you able to use them efficiently? And do you understand states and hooks, right? Are you managing your state properly? Do you have, are you passing in variables or are you using hooks? We also have a portion for security, which is super important, right? We never want to store our API keys in the code. We usually want to have these actually locked behind some server, but in this case, it's okay if you're just reading them from an environment file, so they're not pushed to Git, right? You never want to push your keys to Git, because then your account's compromised and they're going to, charge a bunch of money to your API key. Third, features. So Alchemy University suggested some features in section 4 and 5 of the project guide. So just to give you guys some pointers on the direction of this project, there's 3 points if you're able to implement all the challenges under section 4, and 3 points if you were able to implement at least one challenge from section 5. And then lastly, because this project is kind of open-ended, how creative were you, right? And how's the user interface look? Like, were you able to, is it usable? Can someone actually use this block explorer? And we always want to stress creativity, because some of you guys have made some really amazing projects, especially in weeks 1 and 2, have gotten really creative, and so we added a little section there. I'll pause and just ask, do you guys have questions on this rubric? Is there anything confusing? And in the future, we'll try to get these out today or tomorrow so that you guys know ahead of what to expect, and it's not just dropped on you like on a Wednesday and you're like, oh my God, they're expecting all these things. So we'll do our best to get the rubrics out early. Any questions though? All right, you guys built some awesome explorers. How about questions about week 3 modules? Ethers.js, transactions, JSON RPCs, proof of stake, gas. We also have Al here, so let's put him on the spot. Okay, cool. Then I won't put myself on the spot any longer. Let's jump into student demos. So I think there's a few. Do you have the sheet, Cloud, for the demos? Or
I know a couple people are willing to.
okay. Well,
Nobody's submitted yet.
no one submitted yet?
I mean,
Bapic?
you put it in?
Okay.
Oh, you put it in?
Bapic, let's bring you up here. Come on. Let's give it up for Bapic.
You're gonna use that one?
Okie dokie.
Go,
Yeah,
sir.
I'll just clip it on. It's a little easier. Hello. So, just for the record, I did not finish. Thank you, sir. Yeah, I'll take that.
No one's ever finished.
Oh, dude. It's always stretch goal after stretch goal, right? Okay, let's see if I can get this shit working. Okay. Nice. Okay, we're going. So let me do a clippy here. Not like that Microsoft Word clippy that apparently Bing might be using as its next Google Assistant. Okay, so we got maybe bigger, yeah? Is that cool?
A little bit bigger.
A little bit bigger, okay. I am sorry, my eyes are a little bit better apparently according to Cloud. So we have a lot of files going on here just because I decided to use SAS or SCSS. Lot of different stuff going on here. I was trying to kind of keep it simple, but it did not become simple. So we'll just start up top here. Before we get in the code, let's just look at what's going on here. So I got here. So wait, wrong tab. Do I have a tab up? Here we go. I have so many freaking, yeah, you see all these tabs? This is me trying to figure out what the heck's going on here. So, wrong tab, there we go. There we go, okay. So let's refresh here. Cool, so we got, I wanted to go with like neomorphism as like the UI design just cause like I thought it like looks squishy and I want to squish it like a cloud. Oh, not like you, Cloud. You're squishy, but that's a little different. So the initial idea was to have kind of like a carousel vibe, even though carousels are bad. And I wanted to try and have that you can have like a selector where you can kind of hit like left or right, and then it would like move the blocks kind of like around. You can see how they're kind of styled around. And then if you're on the very left, or if you're on the very like most recent block on the right there, if it was like on there, then it would show like the next one is like waiting, but you can't like select it. But once it, as soon as it like kind of like as soon as it like registers and like actually gets mined and like you can register it through the API, then it would like then you can like switch it and like you can make that centered. And then the idea was with whichever block was here, I was trying to get like a transaction component here where you would have all your transactions here and you could select from here, which would update the window on the right with the individual transaction. But state management is a little difficult, and I'm kind of still learning kind of some of the core fundamentals here, like not let alone like CSS and kind of like React, like state management and use effect and all these things. So top level here, let's just kind of like close out of all of my insane tabs here. So we have an app.js over here, basic thing. We have a block list in the transaction container. Transaction container basically just like having both of those two components underneath, which is your transaction list from like all of your transactions from your current block that you're focusing on, and then your individual transaction, which I have not programmed anything into yet. And then we have up top, we have a block list. This is like kind of where most of the fun stuff was going on. So we have a lot of different use states, which I probably could have done through an array. But I was just like, I'm trying not to debug that hard right now. So I'm just gonna make it separate and the user can just deal with the memory issues. And then we also have kind of like just the set states here. And then we have the 5 different blocks going on. The fun stuff going on with this though, is because we have these, where are we at? In each individual block type, we have like types of blocks, which is your left, middle, right, and then I'm using that to influence the actual class selector here. So if it's on the far left, then we'll be using the styles for the block on the far left, which we can find through here. And then we'll have, down at the bottom here, we have like I'm using transform and perspective and stuff with scale and z-index to kind of push it far. If we kind of look back here, it kind of looks like it's like fading away. I did wanted to get it to, so it's just like transitioning nicely, but yeah, we're not there yet. So, but yeah, long story short, it's just like, I just wanted to kind of focus on like more of the design and kind of like really figure out like state management and stuff. And I can only go so fast as like I know. And I kind of want to touch on, just for a second, on just for the other students in the class here. I was pretty unfamiliar with all this stuff to start. And I think it really just came down to like how much time I was willing to put in. Like I really was like stressing out about getting the project done. Like I was talking to Namdar about this too. We were just like stressing out trying to get this thing done. But then he kind of gave me like a breath of fresh air because I had to realize it's not about finishing the project. It's about learning something. Like, why are we even here? We're not trying to finish something. We're trying to understand what to do so we can apply those skills in the future. So, long story short, I was like super stressed on my job, trying to juggle this and that, and like trying to complete this project. And I think it really came down to, okay, let's just take a step back. What do I need to focus on? And then, because I didn't really know all the stuff I was doing, I kind of relied on some of the expertise of some of the mentors here, which is like another resource that we have. So I would really recommend, like Cloud, you helped a real lot yesterday when I was here in office, and I probably would have not done a lot of this if you hadn't helped. So thank you, sir. So yeah.
You want to just call up Namdar next?
Namdar, rad man. Rad man. There you go, man. Go for it, bro. And then I will place this here, nice, sir. Oh, yes. There you go.
So full disclosure, I am not as good as design as Bapic here, but we got something working. So this is the home page. If you click on gas, it goes to the current gas estimator, which isn't working right now. Nothing is working right now.
That's always how it goes. Are you connected to Wi-Fi now?
Actually, yeah, that might be.
You might have to do the captain.
Yeah, the captive thing. Start googling some. There we go.
There we go. Cool. So now this is the home. So this is the most current block. If you click on gas, this is the current gas price. If we click on chain, we can see the last 10 blocks. So 87, 86, 85. If we click on a certain block, we get the transaction information. And then if we go down and we click, we get the transaction details. I have a little search. I don't know how well it works, to be honest.
What are you searching for?
The block number. It's supposed to be the block number, but it's not showing all the information. And then the chain. So this is from like 80, 78.
So once you search.
Once you search, it keeps the state across the whole thing. I don't know why the transaction routes aren't showing up, but you can click on that and then you can see the. Go home. Back to normal. Oh.
Do you want to show your code because you did things a little different?
Yes.
Walk through like your links and
Yeah. So I didn't do this on purpose, but I realized like halfway through making this thing, I was only using ChatGPT to do it. So I kind of was like, I thought it'd be a fun experiment to like not use Google at all throughout the whole, see where I got me. And then I kind of showed Cloud what I was doing, and he said I was mixing old React with new React. That's correct, right?
functional components.
Yeah, I was mixing like functional command. So that's just like a thing to keep in mind if using ChatGPT. But my
Is ChatGPT giving you an older style?
yeah.
design?
Yeah. Hopefully 4 fixes that. But so this is where you come into like the web page. This would be like the home. First, it just gets the certain block. This is to check for functions for searching, and then this is the nav bar. And so I kind of had to use like a routes.js file to like create these different pages, and then I had to go to index.js and then copy paste that same route path. And then this is where I was sending in the components, and then these are where all my components are, and I was just kind of like rendering these when you got to /page or / whatever. But I don't think this is the best way to do it.
There's no best way.
There's no best way. But
It's just you know preference. So there's just alright. The phone didn't turn on. Hello.
Which mic is that? He or?
Both of them.
Hello.
Is it on?
Hello?
there he is.
Hello? 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 Okay.
But
Yeah, there's no necessary best or proper, but there React has beta docs. So if you go to the documentation for current React, you will kind of see what is like class-based components and all of that jazz. But if you type in React docs beta, you'll see more stuff about functional components. And functional components, these hooks, I think is probably the preferred way to learn. Of course, you're going to want that exposure to the class, because you never know if you're jumping into a code base.
Right.
They were using it.
Yeah.
But just like moving forward, yeah, using functional components, it's just they're a little bit easier to wrap your mind around, and it's less code as well. So, but there's nothing proper or wrong. You know, it's all React.
It's all React. Yeah. Yeah, that's it.
Cool.
Thank you guys. Oh, shout out to Cloud and Bapic, Chad and Chase. Last night we were just dealing with this. So thank you guys. Sam, please. Sir.
hearing Sam over here. I'm just sitting hearing Sam speed at the freaking speed of light over here. He's over here pushing it. Sam over here cutting faster than I've ever seen.
Jesus.
What do you do, Sam?
Band-aids didn't work. No. Got the lotion? Let me take this off as well. So yeah, I was put this on.
What's the price of grin right now?
Not doing good, that's for sure. Okay. All right. Well, I too didn't finish. Good job, Bapic. That was pretty cool. I like that you used neomorphic design because in the office last week, we were just all like, I can't remember who, but some of my team was like talking about neomorphics because they didn't know. And I was like, you guys don't know what neomorphics, and they're pulling it up. It's pretty cool. So I didn't do that, unfortunately. But I did take inspiration from a company that I think like a really big company, right? Because you want to go off after like someone who knows what they're doing, right? So this company, everyone knows it. You probably heard of it. I think they pulled in. It's not Apple, first of all, because everyone goes to Apple. But this company pulled in like over $1 billion in 2018, so they're a big deal, right? They're a pretty big deal, and so they have had a design for their software since like. It's such a good design that they haven't changed it in probably like 10 years, probably even longer, right? Such a good quality design software. So if you guys don't know what I'm talking about by now, the answer to that is, how do I go there? It's called Craigslist. So yeah, so obviously I created change list, right? So you have your other change lists over here, Ethereum, Polygon, envelope. Those don't work, okay? I really tried. But you have all your blocks, your most recent blocks right here, so I can click on one and then you see the block post. Oh, cool. Wow. And yeah, so this design was really hard to get right. It's just the quality of like the font and all that, man. But yeah, this one's finalized. You got some other use list buttons up here. The block number, the hash, details. I could go to the parent, right? I could click back and forth up here, so that's pretty cool. And this is all like routed by like the hash URL, so my little router I've built into there. Nice. And then you have all the transactions, of course. You can click on those. Those are the transaction details. So yeah, that's pretty much it. Yeah, you got not too bad, except one last thing. Of course, this wouldn't be full if you can't create a transaction. So yeah, I created a little form here, but it doesn't work. So that was it. Like I'm trying to do this, and I'm getting some value issues. So I don't know. Nice. That didn't work. But then form input data to getting into the transaction didn't quite work, but that would have been cool. But yeah, that's it.
Wow. Can you show your code as well?
What's up?
Can you show your code?
Yeah. It's not pretty, so yeah, I'm gonna get rid of some stuff. So let's see here. Bump it up. There we go. Can you guys still hear me when I turn my neck this way? I'm gonna just put it over here, just in case. Okay. So I'll start at the top here. So the CSS to accomplish this, first of all, was just some minor tweaks because I just copy and pasted their entire CSS file. And the hardest part of this whole stint was, kind of migrating that code over to something that React wouldn't barf on. And then the other hard part was actually creating like the screens. I just like copy and ripped the code out of the website and cleaned it up a little bit. Kept like the IDs and class names and things like that, renamed it. So they have such a they did some really stupid things. I was just like, okay, I'm just gonna leave it. But yeah, so here's the homepage, right? I'll start at, the app. So the app has basically a little router here that I built. Use URI hash, right? If we open up that, it's just a little effect that tracks the hash change, right? So we got the URI hash, and then I
chop off the hash part of the URI, and that's the query, right? And then that ultimately is used to figure out, have we selected a block? Have we selected a transaction? Those sort of things. And then down at the bottom, I just check, does the query equal create? Then we go to create screen. If there's a selected block, go to the block screen. If there's a TX, go to the TX screen. Otherwise, default to the home screen, right? The home screen just contains blocks that I queried from this custom hook called use block query. You get a count, and this goes ahead and uses the Alchemy. Created a little hook for that. Use Alchemy, right? And then I pulled this hook out of my work called use async value that I created, because it's very, very handy. If you guys don't know what this does, obviously you guys don't know what this does, but this is like use effect, but it kind of does some safe things, like it cancels the previous asynchronous query, because if you don't do that, you get a race condition. If you're doing a lot of queries on a bunch of re-renders, you're going to potentially get the previous query's value versus the latest. So that's all this kind of does, and it's really nice. So I could just say, give me a block number, and that's what this asynchronous function is going to return. You give it a dependency list, of course. It's also an array because, so I got a block number from the core API, and then I passed that block number as a dependency for this asynchronous value, which is the blocks, right? And the blocks are basically a loop over like the count all the way back. So I'm getting a block with transaction all the way back. And this returns, blocks down here. And yeah, if you see the second value, this is the error. I'm returning that just in case. So if there's an error in this query, you can show it. So yeah, that's the use block query. That's what gets me the blocks for the home screen. Dipping into the home screen, you can see it's just a bunch of garbage. We kind of looked at that. Looped over the blocks, that sort of thing. When you click on this block here, link, I created a link component, which is just the anchor tag, basically. And yeah, so that just says navigate to the block / number. And so once we go to block / number, then we can get, you know, we basically have that as our query here, or /block / number. And then what we do is say, hey, does it have this block part in the path in the query? And if so, then we're going to chop that off, and that's the query for blocks. And we're basically finding a block in our block, one of those numbers that matches, and that will return a selected block, right? So once we have a selected block, of course, we show the block screen. And yeah, it's a lot. It's a lot of, I comment out some stuff just in case I needed it. But yeah, there's a lot of HTML I just ripped out because the goal was to make this look as much like the original site as possible. So yeah, that's pretty much it. And then you have like back and forward, the navigation stuff. We get all the details down here. I think I did all the details right here. This is just the block screen accepting a block object from the Alchemy API. Similarly, transaction, similar thing for transaction. Transaction screen is similar, you know, just kind of display the transaction data. The hard part was, and I didn't finish, what I was trying this morning was the create screen. This one's kind of fun because it's a form, right? I expedited a lot of the work by just creating this use input value hook, which is just returning a value and a change in an object, right? So the value is going to be whatever default value you give it, and on change will set that value, right? Very simple. This allows me to create this object that has a value and change that I can just plop or spread into the input component. So it makes it really easy. Got that done. And that way, as you type in the input, you're getting these values. I didn't finish the form submission, unfortunately. I got the default nonce going. The problem was, for whatever reason, parseInt is barfing on the value. I don't know why. It's something like, hey, this is not a value for parseInt. It's like a string. Parse units. Well, I was doing parse ether. So if you guys want to help me debug that later, probably get that to work. And then ultimately, the goal would be you sign the transaction, you send the transaction. I was going to use Polygon as the chain ID, right? Because it's cheap and I wanted to test it before. And and then just direct to that transaction. As soon as you send it, boom, you go to the transaction, see if that would work. Probably wouldn't, because now that I think about it, you need to have that in the block data set. Or maybe not. I could query it. We'll see. I don't know.
Pending screen, maybe.
Pending screen, yeah. Little spinny circle.
One question.
Yeah.
What was your process for porting over like the CSS and the HTML from Craigslist? Like, just go in the source and just, like, save the CSS file?
Oh, okay, yeah. Well, short answer, frantic. Long answer, I just went ahead and opened up the debugger right here. And then I just, refreshed, go to CSS. They have like one CSS file. And I just copied this whole thing over, right? But the thing is, when you paste this, there's a lot of things that React will complain about, like URLs and stuff. So I had to do like find and replace all URLs, match that, and replace it with none. So that's why a lot of icons are broken. I would have liked that to make all that polished up, but I was like, I gotta go quick. Like, I had only yesterday to do this. I don't know why I always do it last minute, but yeah. That was the process for the CSS. For the HTML, what I would do is I would take this whole body. I noticed that like they have this body class that kind of determines the structure of the page. So I kind of put that as the first div element. I just yanked those classes over. And then for the like wrapper and all this stuff, I just right-clicked, edit HTML, selected all that, and pasted it over. And that was a pain in the butt because there'd be like anchors or like images without a slash at the end, because the single inline elements, you need a slash at the end. They did like old school HTML where it's like okay to do that, and I get why, because it's Craigslist. And so that was just a pain going through each one and solving that. And once you had it, I was like, all right, cool, don't touch it. Because I just wanted to kind of bake that look in. So that was kind of the process there. Yeah, cool.
Any other last minute presentations?
That was crazy.
Tired.
No, I don't need my. I just for the live stream. They don't.
We're not going to be imparting any information here. I thought they were all fantastic, and they're all, it's interesting to see the design departures. Every person kind of can get widely different. I'm not sure if I'm impressed more that Craigslist made $1 billion in 2018 or that you were able to afford it over, but it looked great. The only constructive criticism I would say, because I think they're all great, and kudos for presenting something that you isn't polished in front of a group of people, because that's always tough. One of the things I was just looking at, I think they're all kind of beautiful in their own way. Just keep in mind what a block explorer is for. Like, what would you use it for? Like, why are you going to go to a block explorer? Like, what kind of information are you going to get? How are you going to get that information? And, Etherscan is, they've got a bunch of people working on it. But one of the things is, like, why do you need to interrogate a chain? Like, what are you looking for? And just keep that in mind with, maybe functionality and how to display information or how to allow a user to get the information they might want. But a block explorer is really tough because a lot of different people are going to be using it for different things, right? Like, I need to do this or I need to do that. So it's a really high bar to hit, a really interesting challenge, which is probably why they stuck it in. But I think it was all great. And then I would just say, like, why would I go to what kind of information would I go to a block explorer for? What am I looking for and how can it help me? And then in future projects, maybe consider that as well into the design elements. But I think they're all, great job, everyone. Good job. But better than what I would do, that's for sure.
Awesome. Well, great job, everyone, on the demos. Super impressive, each one of you guys. One more time for all the students. And let's now give it up for Adrian, who's going to be going through week 4 slides. So let's go, Adrian.
Can you guys hear me? All right, yeah. Yeah, shout out to all the demoers. Those are some pretty crazy projects. I don't even know if I could make some of those myself. Because front end isn't my strong suit. But hey, Chad, do you know why it's not showing up here? Yeah, but it's not showing up on my screen. Yeah, but I can't see that on my screen. Oh, I see. Yeah.
So arrow next to slideshow on the right side. There's exit there. If you want the speaker notes and stuff, just escape, and then the
right arrow next to slideshow, and then you can go
Presenter view?
presenter view, and then you can drag that onto your screen, so you can have.
Oh, gotcha. Okay, cool. Thank you. There we go. All right. So this is the day we've all been waiting for. We finally get to learn some Solidity. All right, we're going to start off with a brief overview of week 4. We're going to start off with some Solidity syntax. We're going to learn how to communicate with smart contracts, how to communicate from smart contracts, how to use this new tool called hardhat. We're going to learn about some unit tests, which is really important in Solidity and in blockchain in general. And then we're going to do a quick overview of the weekend project, and I'll give you some hints for that. So what exactly is Solidity? Solidity is an object-oriented, high-level language that is very similar to JavaScript. It's also statically typed to avoid runtime errors. That means that when you compile a program, all of the types of the variables are determined there. That's to avoid errors once the contract is actually deployed. Like I know with some of the other weekend projects with the JavaScript, I know you ran into like some type errors before. That can happen with Solidity because that would lead to some fatal, or could even lead to like loss of funds. Solidity supports inheritance, libraries, and complex user-defined types, and it is used to build smart contracts which can be deployed on the EVM. And I included this little diagram here of the vending machine. I'm sure some of you guys have seen that before, but basically the analogy is that with the vending machine, if you insert some money and you select a product, if you inputted the right amount of money for that product, it will give you that item. And that's basically how a smart contract works. It has some predefined set of logic, and if you interact with a smart contract in a way that works with the logic, it will work with you. So let's take a look at how you define a contract in Solidity. So the first thing you usually see at the top of every file is a license identifier. Generally, you're going to be using like MIT, but there are a variety of different licenses out there. And then next, you're going to see this a lot. This is the pragma Solidity, and then you define the version that you're using. And Solidity actually uses, it's called, I forgot what the exact word for it is, but basically the first number represents a major change, a major update. Yeah, semantic versioning, exactly. So the first part represents like a major update. The second part represents like a minor update, and then the third part represents a bug fix. There actually hasn't been a major upgrade to Solidity yet, so we're still on version like 0.8 point something. I'm not exactly sure what the most recent one is. Yeah, but this is basically how you define a version in Solidity. And did I go one more? And this little up arrow indicates compatibility. Sorry about that. Up to the next minor version. So for example, this one would be compatible with 0.9.4. And then once you define the version, then you can define the actual contract itself. It's kind of like very similar to defining a class in JavaScript. So you write contract and then the name of your contract. And generally, the name of your contract should be the same as the name of the file. So now let's take a look at some of the common data types within Solidity. I wrote a list of them there, but I kind of want to run through this file here to show you how variables are defined within Solidity. So the first thing you do is you define the type of the variable, because like I mentioned before, it's Solidity statically typed, so you need to be able to define the type of the variable before it compiles. So for example, here we define an address, and then after the type, you can define a visibility keyword. And visibility basically determines who can access, or not who, but like, well actually yeah, it's kind of like who can access that. But you have to be aware that visibility doesn't determine like anything that you put out on the blockchain is going to be public. So just because you label a variable private doesn't mean that someone can't view it. It just means that you can't access it from like another contract or something like that, or tamper with it. And another cool thing is that when you label a variable public in Solidity, it actually automatically creates a getter function for it. So like if you were to go out and call this contract like my contract dot owner, it would actually like return the owner variable for you. So you don't have to go out and create a variable like get owner and then write out that code yourself. So here's some examples of some data types in Solidity, like address, a boolean, a uint, and an integer. And so I'll start off with the address first. So the address is actually like a special variable within Solidity that represents an Ethereum address. I think it holds 160 bits, which is like the standard Ethereum address that starts with like an OX. And then you have your booleans, that's either true or false. You have uints and ints. So a uint is similar to an int except that it cannot be negative. And you may be wondering, like, why not just use an int? And you'll actually come to find that when you're writing your contracts, it's actually kind of rare to have to use negative numbers. And so if there's a type that's defined specifically for positive numbers, why not use it? And you also don't have to worry about like numbers running into the negative. So that's kind of like a security component. So yeah, and then down here I also wanted to talk about this constructor, which you're going to be using a lot in your contracts. So the constructor is like a function that runs initially on deployment, and it can be used a lot to set global variables, and it's also used to set like owners of the contract, which we'll learn about later. So for example, here we define some global variables, and then within the constructor we pass some variables that we want to set those variables to. And then there's also some extra variables here that are not covered here. For example, bytes, those are usually used for like partitioning data and can also be used to like represent short strings. There's also mapping, structs, and arrays. We're going to learn more about those in week 5. But yeah, I just listed some of the more common ones there. Now, aside from those data types, Solidity also provides what are called context variables. So when a smart contract is created or when a function is called within it, extra data gets passed to it through those transactions, which can be utilized by you, the developer. You can view important information such as the message sender, block.number, and a lot more. And we'll be looking more into this later on when I show an example of a contract. So what's actually happening under the hood? So when a smart contract is compiled, it produces what's called bytecode. And you guys may have seen this before, like in Etherscan, when you go to the contract section and you scroll down, it's like a bunch of letters and numbers. But what those letters and numbers represent are a bunch of opcodes and operands that are then read by the EVM. So here's an example of like some of the opcodes that are run by the EVM. I think you guys learned about that in week 2 or 3, but this is just like an example of some opcodes that would be run by the EVM to like sum a number in a while loop. But that's essentially what the bytecode represents. Now let's take a look at how to define functions in Solidity. So when you define a function, it usually follows this exact outline. So first you define that it is a function, you define the name of the function, then you define the visibility of the function. There are a few visibilities like, I think it's public, external, internal, and private, and virtual. So that basically defines like where you can call that function from. So here, for example, we have an external function, which means that you can only call this function. You can't call this function from within the same contract. It has to be from an external source. And then after that, you have the type of the function, and then you have the return value. The type of the function, there are 3 different types. I think it's view, pure, and one more. Is it? I can't really think of it on the dot. But what was that? View, pure, and those are like the 2 that I can think of off the top of my head. But essentially, it basically defines what the function does. It's view, pure, and then just no type at all. No type at all indicates that it's changing state on the blockchain. A view function means that it is only viewing the state on the blockchain, and a pure function means that you are not viewing or reading the state. You are just, you are only like performing some sort of operation. Like if you had a function that just said return 1 + 2, that's not interacting with the blockchain in any way, so it could be pure. But this is generally how you outline a function in Solidity. So now let's take a look at communicating with smart contracts. So when a smart contract is compiled, it produces two things, an ABI and bytecode. The bytecode is used by the EVM to actually deploy the contract, and the ABI is used by external applications, mainly front-end applications, to interact with the contract. And then in order to interact with the contract, you need to know its address, and you need to also have its ABI. So for example, here we have like an example of using ethers.js to interact with the contract. So you could define a contract and pass in its address, its ABI, and then a wallet that is going to be used to like sign transactions with it.
Sorry, what exactly is an ABI?
So an ABI is kind of like a human readable JSON file that outlines like the functions within the functions and variables within the contract. I could try to show you an example here. Let me pull over a.
It also stands for application binary.
Yeah, application binary. It's similar to an API. So it doesn't look like they have like.
To the those calls that you're referring to, like the bytecode that's compiled into.
Yeah, it's like one step before. The ABI is human readable, while the so this is like an example of what bytecode looks like. You can't really read this, but the EVM can. Or actually, I can pull up.
Etherscan and look at like the DAI smart contract and get the ABI from there. Maybe that's one option. Another way to think about it is like in C, a header file in a way, kind of like, well, not really that.
You said I go where?
You can just search it. If you search DAI, it'll come up.
DAI.
Yeah, like DAI stablecoin, and Etherscan should index that ABI. If you scroll down into the contract tab, and then scroll past that contract source code.
Yeah, there you go. So it basically outlines like each of the inputs for each function.
Oh, so it's basically like selecting each function.
Yeah.
Like, okay, that's cool. That's cool. So it's an easy way to kind of get a summary of all the different stuff that's going on.
Yeah, exactly.
And by the way, this is covered further in the further weeks of the curriculum, right? But like a good summary of it is just it's not really used by us humans. It's used by front end libraries,
Yeah.
ethers, to be able to communicate with the smart contract because it tells it everything it needs about the smart.
It's like protected information for the binary, right?
Right. Yep. And human root, which is nice.
All right, so now we're going to take a look at hardhat. And hardhat is essentially a Solidity developer environment that greatly simplifies the process of deploying, testing, and interacting with smart contracts. And so I'm going to go ahead and demo what it looks like to deploy a contract on hardhat and show you how easy it is. So let me go ahead and get my terminal and VS Code over on this window. There we go. I'm not familiar with like these screen sharing things. So I'm gonna go ahead and make a new directory here and then cd into that and open it in VS Code. And I'm gonna go ahead and open up a terminal here. I'm on Linux, but all of these commands should be like the same, relatively the same. So what I'm going to do first is I'm going to initialize an npm project, and then the -y that I added there just makes it so that it's using like a default config, so that you don't have to like press enter on everything. And then the next thing I'm going to do is install hardhat inside of this project. And this is going to allow us to initialize a hardhat project. I know. There we go. So now we've installed hardhat. Yeah. And to use hardhat, I'm going to run npx hardhat init. Oh, is it just npx hardhat? There we go. And then, so now it's going to prompt you with a few options. You can either create a JavaScript project, a TypeScript project, or just start from scratch with an empty hardhat config. I'm going to go ahead and create a JavaScript project. I'm going to leave that as a root, add a git ignore. And then, so this is important because it's going to ask you if you want to install some sample project dependencies. And you want to press yes to this because it provides a lot of like extra tooling for testing, which we're going to be using later on. So I'm just going to hit yes to this. And it might take a minute because these are like quite a few packages. But we can see here that after initializing the project, hardhat has gone ahead and set up like a little developer environment for us. We have a contracts folder, a scripts folder, and a test folder. This is just like a default log contract. What I'm going to go ahead and do is just rename this to contract.sol. And I'm just going to go ahead and rewrite this contract to just do something simple. Yes?
So just quick detail there. If anyone's getting introduced to Solidity for the first time, the Solidity extension for these contracts is what?
.sol, yeah. And then you can see that it'll have like the little Ethereum icon next to it. So I'm just gonna make a simple contract that has a variable x. And then I'm gonna make a
Do you want me to use it? Yeah. Okay. Can I just reiterate that point?
yeah.
So the extensions for Solidity are what?
.sol. Yeah.
Thank you.
Did you have to? I can't remember. I've been so long. Did you have to download any extensions?
Oh,
I can't remember, but did you download any extensions for your Solidity for VS Code to recognize Solidity?
Yeah, you have to download. It's like the Solidity. Well, I actually have Solidity extension developed by Hardhat, but I know there's just one that's like Solidity by itself.
There's a linter
yeah.
that you can get.
But yeah, you generally just want to install an extension to recognize Solidity, and then you can install. I know there's other extensions for like Hardhat, and you can install those as you go.
Yeah, so for you new devs, when you get into VS Code, make sure you download something like Solidity. Also, prettier for some of you.
Yeah. All right, so I just made it like a really simple contract that has a global variable x and then a function that changes x, and then a good like standard when you're writing these function parameters is if you're going to change a variable, you want to have like the same variable name with an underscore under it. That's just like a neat little thing to do. It's like standard practice. But yeah, it looks like everything was installed. So I think now what I'm going to go ahead and do is set up my deployment script. So usually I like to like delete all of these comments that they have here and rewrite it so that it works with my contract. So they created some variables that they're using for like deployment, but since our contract doesn't really have these variables, we don't really need this. We don't need this either. What we do need though is these contract variables here. And so basically what Hardhat is doing when it's compiling or deploying is it's getting a contract factory, which it grabs from the ABI, and the contract factory is basically like, you can think of it as a contract factory. It's used to make other contracts, depending on like the address or depending on whatever contract you passed it in. So what I'm going to go ahead and do is compile the contract we just made by running npx hardhat compile. So, and then you can see here that what it created is an artifacts folder with our contract. Oh, did I forget to? Oh yeah, I forgot to save. But
No, he's he's compiling. That would be the deploy script.
Oh yeah, sorry.
Yeah. So that's for his deployment script. Right now, what he's doing is compiling it so that it will recognize. Now you see how the name.
Yeah. So here the name changed. Yeah. So now it's compiled, and this is like I was mentioning earlier, the ABI of our contract. And so what Hardhat is going to do is it's going to fetch that and use it to create a new instance of the contract. And so basically we have to go in here and
Here we go, lock deploy. It is
contract equals await contract. We got to change all these names here. And so this passes in some values, but we don't really need that since ours doesn't have any constructor. So, and then this, just to recap, this fetches the contract factory, and then this line creates or deploys a contract from that contract factory. And then this line here basically just awaits that contract to be deployed. And then we can rewrite this to be contract deployed to contract.address. There we go. But before we can deploy this, we actually have to configure our hardhat config to include a network. So I'm going to go ahead and just copy paste this config that I have in another file, and I'll explain what I changed. So basically what I added is a networks section that outlines what networks we want to use when deploying. So here I listed that I want my goerli network. And then you have a URL, which is the Alchemy RPC URL. I'm going to go ahead and set up the .env file right here in a second. And then we also have an accounts, which determines what private key an account we want to use to deploy the contract. So next, I'm going to set up the .env. So what we want to do is install .env. So it looks like that was installed, and then I'm going to go ahead and make a .env file. And then if we want it to work, we have to include a require .env.config. I think that's how you do it. So this recognizes that, okay, we're using .env to pass in these variables here. So I'm actually going to go ahead and disconnect a little bit while I set up my env file. No, I can't have you guys snooping in on my private keys. So give me.
Making a new address if you haven't already.
Yeah.
Just in case.
Let me go ahead and
Yeah, bro, I'll freaking dox you, dude.
dox and steal all my testnet ETH. Okay, so I have my .env set up. So now if we run npx hardhat, so the way that you run the deployment script is you type npx hardhat run scripts/deploy.js. Oh, you guys can see this. Oh, yeah, I see. So you run npx hardhat run scripts/deploy.js. So that's where the file is located in the scripts folder. And then you want to specify which network you want to use. So in this case, we're using goerli. So I would add the network tag and then goerli. Press enter. And now it should deploy. Might take a minute because it's on the actual testnet, but
I would recommend closing your ENV tab just.
Yeah, just in case. Just in case. Just in case.
Make sure you're on that X when you
Just in case.
Is everyone, I'm curious, is everyone well aware what .env does, or microphone at this point? Yeah, right?
I believe that everyone understands why we use environment variables and the security behind it. We went over that in week 3, so I think everyone's pretty up to speed
Yeah,
there.
I mean, I wouldn't want to have my private key just typed out here,
If you don't, I'm going to hammer you in 6 and 7.
There's also more secure ways than a .env. You can even set these variables in a terminal. I mean, there's security risk there too, because you can actually type in history in your terminal, right?
Yeah.
And see all of the things that were called, so you'd make sure you always want to clear history. But the best way to do it, like Chad said, is gating that behind a server, right? So
Yeah. I actually cleared the. Yeah. And actually, part of the grade for this week too is going to be properly configuring your environment variables. So yeah, we can see that the contract has been deployed on the goerli network. So if we actually take this And then, how do I open my Firefox? Probably have to drag this back, yeah. There we go. And if we actually go and paste the, oh, that's the wrong, let's just act like I didn't do that. I know.
We're live streaming.
No one saw that. No one saw
Someone's like,
that.
I'm using this alchemy key. So.
That always happens.
Okay, now, hopefully this is it.
Clipboard extensions or
Yeah, and so now we can see that our contract was successfully deployed. Our contract isn't verified, so it's only going to be bytecode, but you know, see, like, basically the point of that demonstration was to show you how easy it is to actually set up a hardhat project and deploy a contract. So we're going to come back to hardhat later when I want to take a look at some unit tests later on, but I want to continue talking more about Solidity. So we're going to take a look at something called reverts. So basically when a transaction is reverted, it means that the transaction does not get included within a block. And you can use, yes?
That's not true.
Oh, sorry. Well, it gets included within a block, but it doesn't like go through, like the transaction doesn't execute.
So just for clarity, if you write a transaction that reverts, every miner will run that code, which sucks. 'Cause I didn't know that either, and someone told me that. However, no state is changed in that transaction, right? So you actually wouldn't write any, like, as you're running through as that code executes, if you said change x to 10, you change x to 10 and then it reverts later, x won't get written to 10, but every miner will run that bad code that you just wrote.
And so there are actually keywords within Solidity that you can use to revert a transaction. The main one that you're going to see a lot is require. It's basically checking to see if some condition is met, and if it's not, then it reverts the transaction. There's also other keywords like assert, which is used to check for internal errors. And then there's just the plain like keyword that just says revert, and you can use that to like manually revert after a certain condition. And so this here is called a modifier, and you can use it to like easily restrict access within your contract and also like a lot of other things. But for example, here we have a modifier called only owner, which requires that the message sender of the transaction is equal to the owner. And you can assume that there's like some global variable at the top of the contract that's defined as the owner. And so this is how you define a modifier. You say modifier, the name of the modifier, and then in brackets what you want it to check. And then when you end the modifier, you want to have this little underscore with a semicolon that basically indicates to run the body of the function that it's in. And so then once you have the modifier ready, you can add it to a function to indicate that the function should check that it follows the modifier before running. So for example here, in this function setC, which basically just configures a variable to the argument, it would first check to make sure that the person running the transaction is the owner before actually running the rest of the body. So before I continue, I want to give a little refresher on Ethereum addresses because we're going to be talking about how you interact with certain addresses from a contract. So if you guys remember, there's addresses that are EOAs, externally owned accounts. These are derived from a private key and can sign transactions. And then there's also the other type, which is smart contract addresses, which are linked to smart contract code and responds to inputs sent by other contracts or EOAs. And if you guys are actually curious how smart contract addresses are derived, they're actually derived from the hash of their sender's address and the sender's nonce, which if you guys remember, keeps track of the amount of transactions they've sent.
Just a little query. I know we have like collision resistance with like the hashes and stuff, but theoretically, is there a possibility that that smart contract has its own private key to derive its own public address?
is it possible to have for the smart contract to have its own private key in terms of like, because I know it's not generated that way, and I know it's not collision resistant in the way that hashes are made, but is that possible?
Sam has an answer.
Yeah. Oh, sorry. There you go. Oh, just push up.
Oh, there we go. Okay. So I do recall, but you have to check me on this. I do recall reading an EIP that changes the standard from using the sender's contract address plus nonce to determine the contract address to a more deterministic contract address. And I cannot recall what that EIP was, but there is another way out there. And this could be, I could be wrong in that this is the old way and this is the new way, what's being described here. But I can't recall. But I do think there's alternatives out there, alternative standards.
For smart contracts specifically, if you want to create a deterministic address, you can use a create2 opcode, and it has a few more parameters that are used. So it's actually based on you can only deploy that type of contract from another contract. So create2 is one contract deploying another contract, and the address of that contract is based on the code of that contract that it's being deployed, a nonce or a salt, and then one other parameter that I'm forgetting. So it's a little bit different from generating an EOA. I don't know if that was...
That might be what I was
That's
talking
the
about.
question, though,
when I read,
is
so.
does a smart contract have a private key, right?
I mean, yeah, but that doesn't really
I think he's asking, like, is there a chance that a contract address could be linked to, like, a private key of another EOA? Like,
Oh, I see. I mean, sure. Yeah,
Yeah.
you say theoretically, it's possible. It's like, yeah. Are you gonna observe that in reality? I doubt it.
so first we're going to take a look at interacting with externally owned address from a smart contract. So functions and addresses in Solidity can be declared as payable, which means that you can send Ether to them and they are allowed to receive Ether. So for example here, this receive function, and this receive function is actually different from a normal function. It's actually a function that runs when a contract is sent Ether directly, like not through a function. But it's still labeled payable because it is meant to receive Ether. And then once you're within the receive function, this is what runs. And then here in this example, we have addresses that are externally owned addresses, author1 and author2. And you can send Ether to them using this built-in call function. The call function is basically, it takes parameters and call data. So you can send value or data through it and like Ether value through it. But when you're sending Ether to an EOA, you don't really need to send data to it because it's not like a contract. It's not going to do anything with that data. But yeah, this is an example of how you might send Ether to an EOA. So first you define a Boolean success that is linked to the call to the address. And then after the call goes through, you basically want to require that the transfer was successful. And if it doesn't, then it'll revert. But yeah, this is like generally how you would call an externally owned address to send Ether to it. Then you have the other side, which is interacting with contract addresses. And this is generally done using something called interfaces. So an interface is something that lets you easily communicate with other contracts without having to include their complete implementation. So you only need enough information for the EVM to know what function you are attempting to call. So here we defined an interface called iHero. And within iHero, we basically laid out a function declaration, but we don't actually tell it what's happening within the function. We only tell it that it's a function, the name of the function, the type, and if it had any parameters or return types, we would also write that out too. And you can imagine that within a hero contract that's somewhere else in another file, they have an alert function that's actually like written out and has a body. So now within our sidekick function, what we can do is pass in an address for a hero contract and then define it as an interface hero contract and then pass in the address and call the alert function. And because we passed in an address for a hero contract, Solidity will know that we are that we are attempting to call an alert function within the hero contract. So this is actually what's happening like behind the scenes, behind the like the interface. So similarly to how we use the call function to call externally owned addresses, we can also use the call function to pass the encoded method that we wish to run on the other contract. So the way it works is that you take the hash of the name of the function that you wish to call, and then you take the first 4 bytes of that, and then you call the other contract with those like 4 bytes. So yeah, it's kind of a long process, but there's also another function called ABI encode with signature that kind of does this whole work for you. So what you could do is say ABI.encode with signature, pass in the function you wish to call, and then you can also include like arguments that you wish to pass into the function. So it basically simplifies this whole process into like one line. But this is essentially what's happening when you're using this interface, because like you define the function and then you tell it which, you define the function, which is kind of like what we're doing here, like taking the hash of that in the 4 bytes, and then you're calling it on the actual like interface contract linked to the actual contract. I know it's kind of confusing. I'll kind of pause here and see if anyone has questions, but yeah.
What is the external mean? So function alert external.
So
It can be called externally.
Mhm.
Calling it, you're letting now you're calling external.
Yeah, like that's like the visibility
But
of
alert is a function of iHero, right?
yes, alert is a function of iHero and the actual hero contract. So you can imagine that there's another file called like hero.sol, and there it has an alert function like listed out. It'll have the exact same function definition, but it'll actually have the body within it. So this is kind of just like, it's an interface. It's not like the whole thing, but it lets you call it. So now I want to kind of go back to hardhat and take a look at some unit tests. Like I mentioned in the beginning, unit tests are especially important in Solidity because mistakes are irreversible and can lead to loss of funds. And lucky for us, hardhat actually provides a suite of testing tools that we can use to test our contracts. So I'm going to go to another project that I have ready here. I already have some tests written out for a function. I just want to kind of run through how they work and what they're doing. So I'll close this for safety reasons. So I have a contract here called pet shop. Basically what it does is it defines an owner. It has a pet 1, pet 2. The constructor, what it does is it sets the owner address to the message.sender. So because the constructor runs on deployment, it's going to set the owner to whoever deployed the contract. And then I have a few functions here called buy dog or buy cat. You just basically just pass in the pet you want to buy, and it sets pet 1 equal to this and pet 2 equal to that. And then we also have a modifier down here called only owner, kind of like we looked at on the other slide. What it does is it ensures that the message sender of these functions is the owner that we predefined within the constructor. So what it's saying is that if the owner isn't the person who deployed the contract, it won't run.
What's the memory?
Oh yeah, so in Solidity, when you have what is the word for like the data types that need allocation?
Reference types.
Yeah, when you have reference types like a string or array, something that's like dynamically allocated, you need to define where you want it in memory, because the EVM needs to know where to store those data. So you can either choose to save it to memory or storage. Memory is like temporary, and it'll only exist during the function, and then it won't be stored on the blockchain. If you choose to save it to storage, then you can access it later on, but it'll cost more to store, and it's not as like gas efficient. So yeah, so usually when you're passing in like a parameter through a function, you only really need to use it during that function, so you'll usually define it as memory. But But yeah, that's only for reference types or things that are like dynamically allocated.
Typically, your strings are going to be bytes.
Mm-hmm.
There's different types, but bytes, array, and that normally
Microphone.
to be passed with memory.
Yeah. One other thing I forgot to mention is that yeah. One other thing I forgot to mention is that in Solidity there are different like types of variables you can have. For example, what I wrote here is a uint 256. So if you guys remember, a uint is an unsigned integer, which means it can only be positive. But you can define the size of the uint you want, and basically it determines how large that number can be. So there's like uint 256. There's also like uint 80, I think. But I think, and also the default is 256. But one neat thing you can do, and you guys will learn about this later on when you guys are learning about like how to be gas efficient, is you can organize your variables in order of like byte size. Yeah, byte size to like fit in a what is like the size of a? It's like 256, right? Yeah.
256 bits, which is 32 bytes. That's the word size of the machine you're on.
Yeah. So one neat thing you can do is like say you had like 3 variables that at 3 uints of what is 256 divided by 3? Like someone do the math real quick. Yeah, like if you had uints that added up to 256, you could order them in a way that like adds up and fits in that slot, in that like memory slot nicely to actually save memory and be more gas efficient. But yeah, typically you're going to be using like uint 256. It depends on like how large of a number you're trying to store.
One note is Solidity, the compiler, it's cheaper to use uint 256 than like a uint 80. Even though you might only need a uint 80, a lot of times the opcodes, it is because uint 256 is used so often, the compiler has optimized for uint 256. So what Adrian is talking about is being efficient with your memory layout, which is cheaper, which you should do, which we can talk about later. But also, if you just need, typically balances are always declared in uint 256 because that's the highest number you can go with these balances, and they have 18 decimals of resolution typically. So you're always using that for balances, so you'll see it all the time. But if you're needing a variable, an integer variable, usually using a uint without the 256 will default to a uint 256, and those are usually the ones that will be more efficient. And also, when you go to grab a variable declaration, you're probably just going to use uint 256.
And the compiler's optimized for that, so it's really weird. It's like, I don't need that much space, but it's cheaper.
Yep. So now I actually want to take a look at some of these tests that I wrote for the pet shop contract. So at the top here, we have we're basically importing an assert tool that's from the package called chai. That's automatically installed when you say yes to the prompt when you make the project. That's like, do you want to install the extra dependencies? So that's why I said it's really important to say yes to that, because it automatically like gives you the tools you need to test your contracts. So then this is like the basic layout of a test file. You have this describe function first, which basically outlines like what you are testing. So here we have a describe pet shop because we are testing the pet shop contract. And then you initialize the contract in this before function. So you basically go through all the work of deploying the contract. And it's actually deploying to a local blockchain. It's called the hardhat runtime environment. So it's not deployed on like any testnet or anything. It's all local, but it lets you like interact with it and test it really easily. So what we're doing here in this before function is initializing the contract, getting the contract factory, deploying the contract on the local environment, awaiting that the contract is deployed, and then here are where we have our actual tests. So it's really simple to define the test because it's almost like you're reading a sentence of like what you want it to do. If you read this all out, it's like it should fail when another account attempts to set a config variable. And that's what it should do. If an account that isn't the owner attempts to set a config variable, then it should fail. So I defined a little array here with some pets, and then I defined an account that isn't the owner by getting the signer from ethers, and then I did a little for loop to loop through the function and call both of the methods, passing in the pets, and then I did a try and catch here to see if it would give an exception. So because that's what I'm expecting to happen. So I connected to the contract using the account that isn't the owner, and then I called the methods, passing in this method name variable. It's basically just by dog or by pet, and then I catch an exception, set the exception equal to the exception caught, and if there isn't an exception, then the test fails because we want it to not work.
Just in general for testing, you don't usually look for a success. You usually look for a fail.
Well, you look for both. You look for well. You actually see here that after doing this test, I tested to see if the owner could set a config variable. So yeah, so the first test is testing to see whether someone that isn't the owner isn't able to change the config variables, and then this test is making sure that the owner is able to. Basically the same logic, just like doing the for loop, calling the methods, but this time we're using the owner, and so we don't really have to check for an exception because we want it to work. We just want the test to pass. So
the question was, would you usually do an assert.success?
Is this on? Okay, I can never hear myself. So one thing I wanted to mention that maybe isn't obvious here is that this library with the describe and everything like that is a common JavaScript library called Mocha. Chai was mentioned at the top, but Mocha, if you guys want to look into it a little bit more and further, it's a general purpose testing library. And so your test you can write, like he did, asserting that it actually failed, right? That would be a valid assertion to this test that he wrote. But there are other tests where you assert that it ran correctly without a failure and then some result. So it really depends on what you're trying to test, when you run your function, what you're expecting to happen. And so your assertions that he wrote here really determine like this is the correct thing to have happen. And if this doesn't happen, the test will tell you otherwise. So yeah.
yeah, and then in later weeks we're going to be testing for these things called like events, so you can like assert to see if like an event happened through the smart contract. So yeah, if we want to actually run the tests, we can go ahead and in the terminal run npx hardhat test, and it'll automatically know to look in the test file and run the test that you've outlined. So we just press enter, it'll run the test, and we can see that both of them passed. So yeah, it's really simple to write and run tests within hardhat and in Solidity in general.
Can you show it failing?
Failing. Yeah, I can try. I can just add like an assert. Yeah. You said assert false?
Or like that fail.
Fail.
Maybe just remove the exclamation mark on line 23.
Oh yeah, you're right.
So everyone can see kind of.
So now there's no exclamation mark, so it's going to be expecting an exception. But yeah, we'll just run this, and then we can see that it failed. And then we have the assertion errors. Call to by dog with non-owner did not fail when we wanted it to fail because it wasn't the owner who called it.
So one keyword I'll just say it here super quick. Now, one keyword you mentioned is expect. Just shout out. I think it's part of the chai hook library. That's also a good one for testing because you mentioned like the syntax of just saying like it, and the test should do what the it says, right? The expect is also something I like about that. It's just like expect, X to equal this. So that's another hook, very similar to assert. Just if you guys want to check it out.
And you guys have seen some of this in the modules, right? So those testing pages that you're looking through, that, right, Al, is written with Chai, Mocha?
Yes.
Yeah, yeah. So you guys have some exposure to this. You've seen it in the modules before when we're going through this.
Yeah, so try to get in the habit of like testing every contract you write. Like I myself am like not, I get in the habit of like not writing as many tests as I should, but generally you want to be testing for like every edge case possible, just to be sure. Yeah.
What's a good practice to figure out those test cases?
The edge cases?
Yeah.
I'd say, yeah, you want to go?
Well, there's different like testing methodologies that you can look into, you know, and then they have like test-driven development where you're writing tests before you're even coding with the idea of making sure that the code that you write fits your test, right? So you can look into these methodologies and choose which ones you like. And a lot of teams are going to have their own, right? And you're going to have to abide by that.
Theoretically, that's how we were doing the courses for Alchemy, right? Like we already had the tests written out, and then we had to write the code that solidified that. So if anything, like that kind of gave us some experience against that.
Yeah, absolutely. That's a great way to look at it.
One more thing I'll add is there's other testing libraries that allow you to do automated testing too. This is called fuzzing, and so it'll throw a bunch of sample tests at it. So especially like if there's numerical tests, like if you want to test bounds, and a lot of stuff in DeFi deals with numbers, right? And so you have fuzzing libraries that help you automate some of these tests. So you can look into that. Out of scope, I think, for this, but just something to look forward to as you get better and better at writing tests. Yeah, it throws thousands of tests. You can define your ranges and how many you want.
Data.
Data.
Fuzzing is just garbage data. What happens when you give garbage data to this thing? What happens if you give data to this thing that I didn't expect this thing to deal with?
Yeah, and Solidity is like kind of strange because you also have to worry about like people manipulating like the block, or not manipulating, but like using if you have something in your code that relies on like the block number or time even, like people can manipulate that and use that against your contract. So you have to like check for those things as well. There's a really cool resource called Ethernaut, which is like all about testing for those things and learning about smart contract security. So I'd recommend like taking a look at that when you guys get the chance. So one thing I want to mention for this week is that during week 4, you guys will notice that there's a few mini projects that you guys will be completing within hardhat. It'll be those two guides over there, and then this how to unit test guide. So part of this week's grade is actually going to involve submitting 2 of these projects to your GitHub. So they're like step-by-step walkthroughs, so you don't have to like worry about like completing a challenge or anything like that. But I just want you guys to get in the habit of like uploading some of these like mini projects to your GitHub so you have something to show. And I don't know if you guys want to like take a picture of like to know or write down which ones you guys will be submitting, because you guys will be submitting this one, how to unit test, and then how to modify state.
We'll have the slides, right?
Yeah, you guys will have the slides. So now the weekend project for this week is, the goal of it is to essentially emit a smart contract event. I don't know why they included events in this week's project if you guys are covering it next week, but you guys, but you guys don't actually have to worry about like what's happening with the event. All you guys need to know is that your goal is to call a function. Here, let me actually pull up. Your goal is to call a function that has the event within it. So let me go to the weekend project. So this is a contract called, well, it's just called contract, but it has a function called attempt that emits an event that you are a winner. And your goal is to call the attempt function. However, there is a catch, and the catch is that the message sender cannot be equal to the account or the transaction origin. Now, I know you guys are wondering what is the transaction origin. So it is another reference variable that is provided by Solidity that basically points to the person that originally started the transaction. So when you send out a transaction, it can cause like a chain of other transactions by other contracts. So oftentimes the message sender is not equal to the transaction origin, because each one of those or transactions in the chain has its own message sender. So you have to find a way to call this function without being the originator of the transaction. Now the biggest hint I can give you guys is that the message.sender doesn't have to be an externally owned address. It can also be a contract. So you can use that to your advantage. I won't tell you exactly how, but that's like, just keep that in mind, that the message sender does not have to be or an externally owned address. It can also be a contract, because a contract is able to send a transaction to other contracts. And yeah, I think that's about it for the slides. Any questions?
Give it up for Adrian.
I have a couple comments. One, that was a great overview of an introduction to Solidity. I wish I would have gotten that when I was first learning Solidity. Would you mind, can you go back to the VS Code for the initial hardhat when you actually just spun it up from scratch?
Yeah.
And I don't want to get into too much I was sitting here looking at all the Solidity stuff, and I'm like, oh my God, there's so much. So I'm not going to get into any advanced concepts, but I did want to do a couple items. Can you go to your contract Sol? So this is
oh,
your.
my bad. This is a.
Yeah. Not this one. Just a couple items here when you first spin up a hardhat thing. Okay, so see the second line, the pragma. That's where you declare which compiler basically you want to use. You see a little hat there? What do we call it? Caret?
Yeah.
So there's actually 4 options. And you saw this in some of the other code, but we didn't really identify it. You could leave that out, which is recommended when you deploy for real. And that means you're locked. You can't use any other compiler, but like if there was nothing there, it'd be 089, right? You have to use 089 if you ever want to determine what this contract, if this contract was what got deployed, or if I'm interacting with the thing that I think I'm interacting with. The caret means, I don't remember all these, but the caret means something. You can have a less than, you can have a less than equal to, you can have a greater than, you can have other things. So if you're reading contracts and you just see little things in front of that number, it just is denoting different things. And with nothing, it's basically a lock. And this is the recommended approach whenever you deploy for real. You don't want any optionality in your compiler. So I actually have a question for Adrian about, you also said, so when you write a public variable, so you in public X, you get a getter for free, right? So if I call contract.x, I get it for free. It may be the case that you might want to write test functions that say get X. Just sometimes you want to write stuff like that, like get balance. In ERC20, I think, or the NFTs, they come with balance of, even though you might be able to target it. You might want to write little helper functions for yourself. Adrian, my question for you is, so the design style always changes for Solidity, but when you write your parameter for change X with the underscore and then the parameter, that typically is, in your opinion, what does that mean when you put the underscore in front of the X? Opposed to not putting an underscore in front of the X, or putting the underscore after the X. Blow your mind, huh?
Well, honest answer is that's how I've always
I know. So
used,
the question is, they keep moving it around. It used to be nothing. We just wrote this with X, and then it got confusing because you could shadow your publicly declared global variable X. So then we started putting underscores in front of the function parameters. So if it's coming in as a parameter from the function signature, you'd put an underscore. And
Toby, real quick, can you explain what shadowing is? Because it's an important concept in Solidity.
I don't want to get too deep into the weeds here, but basically, so
you mentioned
so
it.
Shadowing. Oh no, happy to. I want to get y'all where your breakout session. But so you can shadow. And this has to do with a little bit of computer science. If you know how the stack works and you know how you're calling functions, where those go, how those get executed. But basically, you're like using what's called a stack, and every time you have an entry point to your program, and then that program, those global variables that are declared in the program will get stored somewhere. And then when you call every function gets loaded up into what's called a stack. And basically, when you run that function, everything gets loaded up. And then when you exit that function, everything gets depleted out, right? So in here, you would say change x gets put on the stack, and then I have a variable uint underscore x gets put on the stack. Well, if I didn't call that underscore x, and I just had uint x there as the function signature, and then I had x equals x, it's up to the OS, it's up to, in this case, the compiler to figure out which x are you referring to. So in that particular instance, I would have shadowed, the global variable x is shadowed, right? And it's shadowing this x I've declared in the function. So when you shadow, it just means like you can't quite see, and you actually push a lot of that onto your system to figure out which one you're talking about. But you shadow basically the declaration of the variable. And typically that's bad programming style, but sometimes you need to do that. And sometimes it's actually you want to do that, but we typically try and delineate which variables we're trying to reference here. So in this particular one, what we usually do now is, well, now I don't know, but there was in like the medium past, you would put an underscore to mean, oh, that's coming into the function, and then that is probably going to be something that has been introduced just within the function. And so when I'm inside this function, I have x and underscore x. So one I know is a global variable because it doesn't have any underscore. The one that has an underscore before the x is a functional variable because that one is the one that's in the function signature, and I know that I'm using that just for the execution of this function. However, now I've seen the underscore after the x, and I'm not sure because you can read this, and I recommend everybody go to the Solidity documentation, and you can see what their design style is. And I think now we do this. I'm not sure. Anyway, you'll see this when you read contracts. I just wanted to point out that you'll see this kind of stuff, and it's referencing how do I delineate between a global variable, a function signature variable that is basically an argument that you're passing in as a parameter, and then there are, other types of things. I can declare a variable inside the function, right? Not in the function signature, but I can also declare one inside the function. And so it's an attempt to try and delineate those things.
So Toby, the underscore after.
You got that one?
Just so.
I wanted to pull the brain space here. What are we doing?
Because I think so the underscore after the variable is for variables that would be declared inside of a function body. Great. Is that what you're saying?
Yeah. So you'll see this stuff, and sometimes you see it, and you're like, oh, I don't know what that means, so I don't care. But you see it a whole bunch, and when you try and figure it out, you're like, well, why did they use this in this particular contract? So the other thing that my point about writing explorers before is in Etherscan. I think what Al said in Etherscan, you can go and look at contracts, and so when you see other people, that's a great way to learn. When you see other people make contracts, you're like, well, how did Compound write their contract? And they have it there. And you can think, oh, well, why did you use the X underscore? What's that mean? So the last thing I wanted to note is this is the one you just spun up, right?
Yeah.
Okay. Let's look at that .get ignore. Oh, sexy. What's that second one say? All right. If you missed that, it's going up in GitHub.
Yeah.
Be very careful of that. I have that in my lecture too because actually I spun up one of these and it didn't have that in there and did push it to GitHub, so it was a big pain in the ass.
So Toby,
just make sure, yeah.
What if I'm working with a group and I want them to know the name of my env variables? How do I share that?
I have something that is not going to be popular in this room about my view of these .env files, so I'm not going to answer that. No, I will put. It's heavily within mine because I don't want to get in there. But would you answer that question because it's a good question?
Yeah,
when you're working in a team, right? We're just doing these like little one-offs. But when you actually do it for real, you're gonna be working with a team of people.
Yeah, I mean, so you probably, if you're really using the .env, and like Toby's saying, this is not the safest way, but you could declare .env.local, right? And then you can have the names pre-prescribed. And then hopefully your team would have some way to pass around these API keys to each other in an encrypted way. That way the names are all standard, right? and then they would go and fill them in. So hopefully that makes sense.
Just a quick note. This is
kind of a shill, but I wrote a library called cleaner configs. That's an alternative to .env if you guys want to check that out. But you gotta dip into some of our like internal stuff, like using cleaners and stuff. Yeah. So anyway, yeah. Full
And
shill.
then one last thing I want to say before, and then I swear we'll break out. There are hardhat, like he said, it has this toolbox. There's tons of tools. So if you're really, really interested in knowing how much gas you're using, if you're really, really interested in knowing how to verify a contract programmatically, they have like the Etherscan gas reporter, right? You can go get an API key from Etherscan. It's going to tell you exactly how much gas you're using, and you can sit there all day and play around and optimize your contracts and find out exactly how this stuff works. You don't just have to guess. Of course, it'll be good to go learn, more of the basics. Also, they have a way to verify through hardhat verify, and that's going to show your contract on chain. So you can look into those tools too, guys.
Just a quick question. Hello. Just a little quick question. So you said you can try and optimize your code to be more gas efficient. I'm curious if there's like some weird way where you can have the automated testing that we were talking about earlier to combine with that kind of gas tester to see if you can get like super efficient and like test friendly code. Is there like an automated way of doing that, or is that like usually a manual method?
I don't know.
We'll save that for a breakout.
Okay.
Yeah.
Cool.
Awesome.
Awesome. Peace.
Let's give it up for Adrian. Awesome, guys. So the last thing I want to do before we break out is real quick. There's a bunch of Alchemy shirts. If you guys can grab one, it'd be really cool to take a picture with Al for the Alchemy team. So if you guys want to put on a shirt, we can just line up here and take a group photo and share it with the team. And yeah, that'd be awesome. Thanks, guys.